This is page 300, number 1. So number 1, we have to sketch the graph of 2x minus 5 over x plus 3. We start off with what we know from pre-calc. So our asymptotes would be x equals negative 3 and y equals 2. Our intercepts will be y equals negative 5/3 and x equals 5/2. Our domain is all reals except negative 3. And our symmetry will not be even and will not be odd. So now we're ready to look at our first derivative. So I'm going to use the quotient rule. We've got x plus 3 times 2 so this will simplify. We've got 2x plus 6 minus 2x plus 5. 2x's cancel, and we end up with 11 over x plus 3 squared. So now we look for our critical numbers. Now the derivative here is never going to be equal to 0, but the derivative is undefined at x equals negative 3. Now, negative 3 is not in the domain of the function, so this is not a critical number, which means that f does not have any critical numbers. Now, if f doesn't have a critical number, then f does not have any local extrema. But we would like to know where our function is increasing or decreasing, so let's set up a sign chart anyway. So we'll have 11 x plus 3 squared and the derivative. So negative infinity to negative 3 to positive infinity. This is always positive, this is always positive, so f prime is always positive. So f of x is increasing because f prime is positive. Okay, now we're ready for our second derivative. So f double prime, well, what I think I'm going to do first, actually, let's rewrite f of x, or f prime of x, is 11 times x plus 3 to the negative 2. So f double prime is negative 22 over x plus 3 cubed. So now, the second derivative is never equal to 0, and the second derivative is undefined at x equals negative 3. Again, x equals negative 3 is not in the domain, so negative 3 cannot be the location of a point of inflection. So we can say that f has no points of inflection. But we would still like to know about the function's concavity, so we're going to make a sign chart. We've got negative 22 x plus 3 cubed and f double prime. Negative 22 is always negative. This will be negative then positive. So our graph goes from concave up to concave down. So we write our statements. F is concave up. And f is concave down. Okay, so now let's put it together and start graphing our functions. I'm going to go back to the top here. And we need some asymptotes. Y equals negative, x equals negative 3 and y equals 2. So x equals negative 3 and y equals 2. we have some intercepts. We know we've got a y-intercept at negative 5/3. So y-intercept at negative 5/3. So let's make that about here. And then our x-intercept is at 5/2. So we'll put that right here. Okay, so now we know that our function is always increasing on its domain, but that our graph goes from concave up to concave down at -3. So we need to go concave up in this section, concave down in this section, but always increasing. So this would have to look like this. Increasing here, concave up. Increasing here, concave down. And remember to label, and that's it.